How far away is the sun in, say, kilometers? The sun is this many kilometers away. It's such a long number, it's actually really hard to read straight away. I have to count all the zeros and try and work it out. So there's 1, 2, 3, 4, 5 zeros, and then another 4 numbers after that. And after a bit of thinking, I can work out that that is 149.6 million kilometers. How about the size of an atom? How big is an atom? If we were to measure an atom in meters, how wide would it be? The answer is its diameter is about this many meters. It's tiny, an atom. We are made up of billions and millions of atoms. So they're really, really small. But how big is that? It's hard to read because there's so many zeros. 0.0000008 meters. That's really small. Last question I'm going to ask is, how many users are there on TikTok? It's really, really popular at the moment. And actually there's loads. Look how many zeros there are. Get on here. 1, 2, 3, 4, 5, 6, 7, 8 zeros. And if I were to read this as a number, that's 800 million people are using TikTok. That's a bigger number than the distance in kilometers from us to the sun. That's amazing. But the problem is, when you look at this slide and you look at these numbers, they're quite hard to read because there's so many zeros in them. And that's a problem that scientists and lots of other people have when they're dealing with these very, very big numbers or these very, very small numbers. They're really difficult to read. So a solution to this is what we call standard form. And standard form is a way of writing numbers which means that we don't have to read out all of these zeros because it's easy to forget some of them, and that will really mess up calculations. So I'm going to give you an example of a number written in standard form, and then I'm going to explain what it is. So let's take the number 3000. 3000, well, I can write that as 3 times by 1000. 3 lots of 1000 is 3000. I can also write this as 3 times 10 to the 3, because I know my powers of 10. And 10 to the 3 is 10 times 10 times 10, which is 1000. And standard form is all about writing numbers and then timesing them by powers of 10. And if a number is in standard form, it always looks like this. So I'm going to just write A for now, and that means a number. And then we times it by 10 to the power of n, so some number n. And there's special things about this. The first one I'm going to say is A is a number between 1 and 10. So it's never smaller than 1, and it's never bigger than 10. And this number n here is going to be a whole number. So it might be positive, it might be negative, but it's always a whole number. Okay, so I'm going to just give you some examples of how to write numbers in standard form. So these first two ones, I've got 2 million and I've got 75,000. So we're going to write this as a number between 1 and 10 times by 10 to the power of something. So I know what my start is. I'm going to write that as 2 times 10 to the something, and I need to work out what that something is. And the way we work it out is we look at how many decimal places has moved. So originally, if we think about this, the decimal place would be here. So we're going to put a little arrow to where it was. And now, when we write it just as 2 times something, it's going to be here. So 2 point this is the same as 2, so it's here. So how many spaces has that point moved? We can count along. So we go 1, 2, 3, 4, 5, 6. It's moved 6, so it's going to be 2 times 10 to the 6. And if I wanted to, I could just check this. If I did 10 to the 6, that's equal to 1,000,000. So 2 million would be 2 times 10 to the 6. So it does work. And I encourage you to initially just to check your answers using your calculator. You can put in 10 to the 6 and see what it is. Okay, and the next one, again, we need to have a number between 1 and 10. So it's tempting here to write 75, but 75 is way bigger than 10. So we're going to write 7.5 times 10 to the something. Now let's see what that is. So our decimal point was originally here at the end of the whole number. And now we've put it here because we've written 7.5. We haven't put it after the 5, we put it after the 7. Okay, so how many has that moved? We've got 1, 2, 3, 4. So that's going to be times 10 to the 4. Alright, what about numbers that are smaller than 1? So these decimal numbers, how do we write these in standard form? Well, the good news is we write them in exactly the same way. So again, we need to find that number between 1 and 10. 0.006. So that number is going to be 6 times 10 to the something. And when we have numbers that are less than 1, we're going to have a negative power on that 10. And the reason why, now we know our indices laws, 10 to the minus 1 is the same as 1 over 10. And as a decimal, that's 0.1. 10 to the minus 2 is the same as 1 over 10 squared. And that's the same as 0.01. And if I carried this on, 10 to the minus 3 would be 0.001. And so we'll have a look again now how many decimal places has this moved, but now it's a small number, it's going to be a negative power on that 10. So we've moved it to here, so it's gone 1, 2, 3. It's going to be a negative 3. We need to pick our number between 1 and 10 again. Now, it's not going to be 45 because that's bigger than 10. It's going to be 4.5. And then we're timesing it by 10 to the something. So let's put our decimal place in here, 4.5. And we're going to see how much it has moved. So we're going to go 1, 2, 3, 4, 5. So it must be times 10 to the minus 5. And lastly, we have 0.1. So our number is going to be 1 times 10 to the something. How many spaces has that decimal point moved? Well, it would be here if it was 1, so it's just moved 1. So it's times 10 to the 1. And that matches up. We've already calculated times 10 to the 1 over here, and it's 0.1. So that's how we put numbers in the standard form. It's also going to be useful to be able to take these numbers in standard form and put them back into the ordinary numbers. So put them back into the numbers that we can read. So here we've got some examples. The first 3 all have positive powers on that 10. So that means that they're all going to be big numbers. The last 2 have negative powers. So that means that they're going to be decimals. Alright, so the first one, we've got 4 times 10 to the 3. Well, that 4 is going to go first. And we now are going to think about how many times this decimal place has moved. We're going to move back this way 3 times. So we're going to go from here, and we're going to go 1, 2, 3, and the new one's going to be here. So how many zeros are we going to put in? We're going to put in 3 zeros, and the answer is going to be 4,000. And we can check that because we know that 10 to the 3 is 1,000. And so it works. 4 times 1,000 is 4,000. The next one, we have 3.27 times 10 to the 5. The decimal point needs to move 5 times. I can already see that it needs to move 1, 2 with those points here. So 3, 2, 7, and that decimal point has moved it twice. It needs to move another 3 times, so I'm going to add 3 zeros on the end and put that decimal point here. And you can just check this really quickly by going, right, where was that point here? And it's gone 1, 2, 3, 4, 5. So that must be the answer. Okay, and the last one, the same thing again. We've got a 10 to the 2 there, so that decimal point needs to move twice. It's going to move once here, 6, 2, and then it needs another 0 on the end to make it move 2 times, 1, 2. And with these negative ones, we're doing exactly the same thing, except we have to move the other way to make it a decimal. So we've got a 1.3 here, so it's going to move 1 to get to there, and then it's going to move another 2 more times, 1, 2. So the new decimal point is going to go there. So that's going to give us 0.0013. And again, we'll just do a little check. So put that point in there. 1, 2, 3. Yes, it's moved 3 times. Wonderful. And the last one, we've got a -6 here. Decimal point is there. That's 1. So we're going to have another 5 zeros, so that it moves 6 times. And we'll just check that. 1, 2, 3, 4, 5, 6. Yes, it's moved 6 times. Perfect. So lastly, just to make sure that the main takeaway from this is a number is in standard form when it is a number between 1 and 10 times by 10 to a power. Just wanted to end by showing you this really cool website. Which allows you to see things, to see how big and how small things are with using this standard form. So let's go right in. The size of a human here is 1.7 times 10 to the 0 meters. So we're about 1.7 meters tall. And you can zoom in really far to see really small things. So an ant is 4 times 10 to the -3 meters. We can keep zooming in and zooming in until we find DNA, 3 times 10 to the -9, or even to an atom like I was talking about earlier, right at the start of the video. We can zoom all the way out to see really, really big things. So here we've got Angel Falls. It's the tallest waterfall in the world. At 9 times 10 to the 2 meters. We can keep zooming out. Here we can see Earth there, the size of Earth. 1 times 10 to the 7. I can keep zooming out and looking at things in the universe. So we've got some nebulas here of stars. We keep zooming out, we can find the Milky Way, all the way to the estimated size of the observable universe. So I'm going to put a link into this website as well, because I think it's really fun to play around with this and see how big things are with just a small number to that 10. So 10 to the 24. 24 doesn't seem like a really big number, and yet it's so massive that it's, almost the size of the observable universe. So I'm going to link that website in as well. Please have a play around with it. I just think it's very cool. Please complete the worksheet, and as usual, mark your work and submit a photo to Google Classrooms.